watching this video, that means that you already went through the other video that talked about what dividing fractions by other fractions looks like visually. This is the retake video that's going to go through a few more examples for you to show you what it actually looks like in practice. As a quick review, when we are dividing fractions by other fractions, there are two algorithms that we're working with. The invert the second fraction and multiply. That's where inverting the second fraction, if you remember, that's called the reciprocal. And that is a vocabulary word that we do need to know, reciprocal. And then you multiply. So you change the division problem into multiplication. The other algorithm is by finding a common denominator and dividing across the fraction. Okay, so as we work through these examples, we're going to show you what it looks like. Before we start, though, I want you to write these 3 steps down into your notes because there are 3 very clear steps for all of these problems. The first step, and it's absolutely necessary, is you have to draw a picture and estimate. I don't want you just starting the problem right away with the math. You might get there eventually, but we are at the age right now where we have to understand what the problem actually means. Because when you talk to even most adults now and ask them, what does 2/3 divided by 1/2 mean, especially as a picture, they probably can't explain it to you. Okay, so we always start with drawing the picture. Now, step 2 and step 3 can be reversed. Okay, so it doesn't really matter which one you pick, but for my step 2, I do the common denominator method because that's actually the algorithm that I like better. They are equal algorithms, though, so they're both fine. And then step 3 here is invert and multiply. And the reason why I like the common denominator algorithm better is because you actually divide in it. The third algorithm, the second algorithm, you end up multiplying during a division problem, and I find that hard to remember. They're both equivalent, but I like dividing in division problems. So let's show what that looks like with this same problem. Step 1, I drew the picture. This is what it looks like, and the question is, how many times can 1/2 divide into 2/3? So how many groups of 1/2 can we fit into 2/3? Well, this is one group right here. Okay, this right here would be the second group. So we know that the answer is going to be between 1 and 2. And that's all we need for the estimation of this problem because 1/2 can fit into 2/3 between 1 and 2 times. So even if you set about 1 time or a little more than 1 time, totally acceptable. Okay, and then I like to split my page right down the middle when I do my 2 algorithms. So I'm going to do the common denominator method on the left, and then on the right, I'm going to do the invert and multiply. So let's start with the common denominator method here on the left. When I look at thirds and halves, I know that the best common denominator or least common denominator is going to be 1/6. Okay? So what I do is I turn these each into 1/6. I multiplied 3 times 2 to get 6, so I do 2 times 2 to get 4/6. Same thing with 1/2. 1/2 is the same as 3/6. Now, once I have the common denominator, the next step, okay, is to divide across. So I'm going to do 4 divided by 3. And then I do 6 divided by 6. This is the part they skipped in the video that I didn't really like. I want you to write this step in. Now, 4 divided by 3 just stays as 4 divided by 3. We can't do anything with that yet, but 6 divided by 6, that should be 1. And this right here is the special moment. You always have to have a 1 because you're dividing by the same denominator. If you don't get this step, you've made a mistake. Once you've divided by 1, anything divided by 1 is not going to change. So we just do 4 divided by 3. We just write that as our improper fraction. That is going to be the same as 1 and 1/3. If we go back to our estimation, 1 and 1/3 is between 1 and 2, so we must have done something right. Now, for invert and multiply, we start over. It's like we didn't do anything in this problem yet. We look back at the original, and we need to find the reciprocal of the second fraction. The second fraction's reciprocal is where you flip it like that, and you end up getting 2 over 1. But then you invert and multiply like that, and we simply multiply across. So 2 times 2 is 4. 3 times 1 is 3. And these end up simplifying out to give us 1 and 1/3. We have to get the same numbers in both answers, or else we've made a mistake. Okay, so there you have the common denominator, invert and multiply, and the picture. This is what your work should look like for every one of these problems. Let's do another. So once again, I drew the picture for you. We have 6/8 divided by 1/4. So the question is, how many 1/4 can fit into 6/8? Well, I know that we have 1 right here. This next part, this would be 2. And the next part here is 3. And it looks like it might actually be right on 3. So let's say about 3. Because even if it looks like it's right on 3, we're still estimating. Okay? And now let's split down the middle. And I'm going to do my common denominator here on the left. Common denominator that would work for this would be 8ths. Let's do 8ths. I have hiccups a little bit. That's not good. So we got 6/8. That's going to stay. And then 1/4. We're going to multiply the numerator and denominator by 2. So we get 2/8. And now we are going to divide across the numerator and across the denominator. Well, 6 divided by 2, that's actually just 3. We can write that as a whole number. And then 8 divided by 8, that's just 1. Oh, look at that. And 3 divided by 1 is actually just 3. Our answer is exactly 3. For invert and multiply, we go back to the original. And we are going to flip the second fraction and make this a multiplication problem. So 6 times 4 is 24. 8 times 1 is 8. And now we have to simplify. Let's divide both of these by 2. So we get 12/4. Let's divide by 2 again. 6/2. And then divide by 2 again. And we get 3 wholes, or just 3. So that actually gave us the same answer for both. And I did these two problems because if you notice in the first problem, invert and multiply was actually faster. In this problem, the common denominator was actually faster. And it will happen like that. You won't really know which is going to be a faster method until you've actually done the problem. Now let's do a little bit tougher. We have 1 1/4 divided by 1/3. Now for the estimation in the picture, we don't need to change this problem at all. So we can just look right here, and I know that I have 1, 2, 3, and then the next one would fit right over here, which is about 4. So I'm going to say that 1/3 can fit into 1 1/4 about 4 times. Okay? And let's break down the problem like this. Common denominator on the left, invert and multiply on the right. But, huge thing in this problem, you cannot at all divide or multiply with that mixed number. You're not going to do that correctly, so I'm going to change this into 5/4 as an improper fraction divided by 1/3. Now I'm going to do my common denominator, which is going to be 12ths. So this will be 15/12 divided by 4/12. Okay? Now I divide across, so I get 15 divided by 4. And here's what most people do is they write divided by 1 on the bottom. They X that out to get 15/4. Now to make this an mixed number, we would get 4/4, 8/4, looks like 12/4 plus an extra 3/4 gives us 3 3/4, which is really close to 4. So it looks like we have the correct answer here. Going back to invert and multiply, we are going to flip the second fraction and multiply to get 15/4, which is what we had right here, So we know that this answer would be 3 3/4. So these are what the actual problems look like. As always, if you have any questions, make sure you come talk to me. But just like we talked about before, there are always 3 steps to every problem.